Welcome friends. Today we will study about the measures of dispersion. We already learned regarding central tendency, which is single representative value of for a set of the data, and this central value cannot shows the topical or cannot shows the total picture of the data. So we use the major variation or measures of dispersion. Measure of dispersions is describes the spread, deviation, variability, scatter, or uh, variability or scatter of individual values around the central value of set of data. The measures of statistical dispersion is a non-negative real number, that is 0. If all the data are the same and increases as the data become more diverse. Then the dispersion is the contrasted with the location or central tendency, and both of these together work as a most used properties of distributions. Now the different measures of variations. These are the following 4 different measures of variations. First one is the range, second one is mean deviation, third one is standard deviation, and fourth one is variance. We will study one by one with example. Okay, see, first one is the range. Range is defined as the difference between the highest value and lowest value in a set of data. It is the size of smallest interval in statistic which contains all the data and provides an indication of the statistical dispersion. It is measured in the same unit as the data, and it only depends on the two observation. Which one is the maximum, that is the highest, and a minimum, that is the lowest observation. And it is most useful in representing the dispersion of the small data set. See, this is range. Range is equal to the maximum observation minus minimum observation is equal to the highest minus lowest. In this, 9 is the highest observation and 3 is the lowest observation. So range is 9 minus 3 is equal to the 6. Now the example, this find the range of the following data. These are the observation, and in this observation 10 is the highest range, highest observation, and 1 is the smallest observation. So range is equal to the 10 minus 1 is equal to 9. What is range is a size of the maximum difference between the maximum and minimum observation. Then next one, second one, merit of the range. Range gives the quick and easy to estimate indication about the spread of data. As a student of statistics, you should understand what kind of the data are the best, found in a defined based on the range. If there are too many outliers, as well as it may not be a good idea, so range gives a quick and easy to estimate the indication about the spread of data. Only 2 values are used in this calculation, highest and the lowest values. It is influenced by an extreme values, and it is easy to compute and understand. In biological studies, it can only indicates the variation into extreme values of the data. It is used in statistical quality control, also used in a meteorological weather forecast. These are the merits of range. Then next one is the mean deviation. It is the mean of all the deviation in a given set of the data obtained from an average. Also, it is related as a positive, or treated as a positive. The mean deviation, absolute deviation of a set of n numbers. So the formula is equal to summation of x minus x bar x bar divided by n number of observation. See, x is the observation, x bar is the mean of all observation, and n is the number of observation. So the example of the four consecutives received from the following bonuses last year, given year bonuses are 14, 15, 17 and 16 in dollars. So now determine the mean absolute deviation. So first step is to determine the mean of all the observation. So mean is the sum of all the observation divided by the number of observations. So 62 divided by 4 is equal to the 15.5. Okay. Now the mean absolute deviation 14 is the first observation minus the mean 15.5, again plus 15 minus 15.5 plus 17 minus 15.5 plus 16 minus 15.5, then divided by the number of observation is equal to the 4.4. 4 by 4 is equal to the 1. This is the mean absolute deviation. See, the choice of measure of central tendency has marked effect on the value of the mean deviation. In measure central tendency, we learned about the mean, median, and mode. Now, from this choice, this measure of central tendency shows the marked effect on the value of mean deviation. For example, this is the data set 2, 2, 3, 4, 14, and their mean is 5. Okay, same as their median is 3 and mode is 2. So now from this mean absolute deviation is 3.6. From this median, this MAD is 2.8. From this mode, this MAD is 3.0. From this observation, the mean absolute deviation from the median is always less than or equal to the mean absolute deviation from any other fixed number, as well as the mean absolute deviation from the mean is less than or equal to the standard deviation. Okay, then merits of this mean absolute deviation. All values are used in the calculation in this mean absolute deviation. Then it is very easy to calculate. It is not unduly influenced by the large or small values, and the absolute values are difficult to manipulate. And it is really it is less reliable because positive and negative signs are ignored. These are about the merits of mean absolute deviation. Thank you.